Yo, I hope you guys are doing well. Let's get into the work. Right. So this is, of course, I've been saying in the past videos that measurement is one of the easiest because you have to memorize the formula and that's it. Right. If they wanna be tricky, it will be like things that you possibly know. Just like this one. This is a perfect example of maybe how they might try to trick you. Because look at this. So they gave us units in millimeters, but when they gave us the volume was in centimeters. You understand? So here, and okay, they say calculate the height h, right? And here, so I want to make you aware that they didn't really say whether our height should be in millimeters or centimeters, right? So you can make your calculations whether in centimeters or in millimeters. You understand? Cool. So for this one, they said even we have to ignore the thickness of the glass, right? And the diameter here is like 50 millimeters. So let's get on to it. The most important thing, you have to always remember the formula. So volume is pi radius squared times height, right? And then the radius, right? Let me just write it here on top. They say that our diameter is 50 millimeters. That means our radius is going to be 25 millimeters. And when you convert this 25 millimeters to centimeters, now it's going to be 2.5 centimeters. Now you have your conversions, everything is fine. You can do the substitution. 250 pi into 2.5 squared, right? We don't know h, so we're gonna divide by pi 2.5 squared by 2.5 squared. Right, and we get the answers 12.73 watt centimeters. Remember, we made our calculation using centimeters. I mean, if you want, you can just say it's going to be 127.330, maybe 32 millimeters. Right, perfect. So I'm gonna continue with centimeters here. Now they say that okay, water is now poured into the glass until it's 65% full, right? And we have to calculate the what is it that we have to calculate? Oh, so we have to calculate the total surface area covered by the water. Yeah, we have to calculate the total surface area covered by the water. So this one, it can be a bit tricky in a sense. The thing is, when I'm thinking of water being poured in a glass, I'm thinking of a volume, right? So yeah, so perhaps if they would ask me like the volume of water that the volume of water, the volume of the water, then I was gonna say 65% times the total volume, right? Yeah, yeah. And then from the water, what can I get? Here's what I can get. The water is 65% full, and that 65% is the distance from here to here. All right. So I can also say that the height of this water is going to be what? It's going to be 65% of the height of the total height. Yeah. So the thing is, I care about my height because I need it for my calculations. And also you'll be aware that what's happening. Okay, let's start with the height. So the height, let me say a height dash will be 0.65 times 12.73. 12.73, and that gives me that gives me 8.27. So 8.27 is my centimeters. It's my height, right, for this guy. And then if I calculate the total surface area, TSA, if I calculate the total surface area for my of the surface covered by water, ne? So now, instead of considering the two circles, remember when you calculate the total surface area, what we will advise you to do is take your shape and break it into nets. You will see for cylinder you have two circles and then one rectangle or a square, and then is the total surface area of the two circles, and is the area of the two circles and the area of the rectangle combined together, you get the total surface area of the right. But now the thing is, instead of considering two, right, we're gonna take one circle, right? And the reason is because, right, you got it. So the reason is because, remember, this thing is not your full, right? And we are only calculating the total surface area covered by the water, right? Covered by the water. That is very important. So you have your pi radius squared, that is the area for one, and then you're gonna have what? Remember the circumference times height, that is 2 pi radius multiplied by the height. So now substitution, that is what? Pi radius 2.5 squared pi 2.5 times height times 8.27. Then the rest is just your calculator and the answer. That squared to pi 2.5 8.27. So you get 149.54 centimeters squared. Oh yeah. And I think with that we conclude this chapter. No. This. Away. Continue with this one. So what we have. You read the instruction, right? I think when you read the instructions, you find the most important terms are these, right? The square base, right? That square base automatically tells you that if we ignore the top part, which is the roof, you have a cube, right? And by a cube, that means all sides equal. No matter what, all sides equal. So you're gonna have 3, 3, 3, 3, and we have to find AH, né? So AH, I think they did us justice. So here's what I want you to think about. So AH is something like this. You have your triangle, right? That is A, B, C, H. That is AH, right? And remember, CB is equals to, or BC, let me say BC is equals to what? BC is equals to 3. Yes. Now, another thing that might be interesting is, so you see these dotted lines, ne? Okay, I would say I think they tried to make the question trickier for you guys. So you see how they put AH on the side. You can even put it on this triangle, the side, right, on this round part. But I guess also with it being on this other side, it allows you to be able to visualize these dotted lines, which the dotted lines from here up until there, it represents the height as well, because it is literally the distance from the peak of the roof down to surface, down to the surface, right, which is 0.8. And then you have the distance here, which, right, will just be half the distance of 3, because that, when you draw like a line, a straight line from the peak down to the surface, né, or down to the base of the roof, it's going to be at the center of the base of the roof, right? That implies the distance from the dotted lines to h is what? A half of 1.3. So you calculating h here, right, you're going to just simply use a Pythagoras theorem to say h squared will be 0.8 squared plus 1.5 squared. Where is this 1.5 squared coming from? Is the half of 3, right, which is the distance for the thing. So 0.8 squared plus 1.5, right, squared, and you get 2.89 as your ah squared. Then when you put, of course, the square root both side, ah is what? Ah is 2.8. Man. Lol. You're gonna get 1.7, right? So that's your height. Then now when they say calculate the surface area of the roof, né? So surface area of the roof, so what's gonna happen is, realize that the triangles of these roofs are going to be identical, right? So you can just calculate the area of one triangle, multiply that by 4, right? So that is going to be, so surface area is going to be 4 multiplied by half base times perpendicular height, right? That gives you like 2 base perpendicular height. We can substitute, right? You have 2, your base is 3, perpendicular height is what? 1.7. We just literally calculated it there above. So you have 2 times 3 times 1.7, and that gives you 10.2 meters squared. Don't forget the squared. Then they say if the height of the wall, right, of the tent is 2.5, calculate the total canvas, the total amount of canvas required to make the tent if the floor is excluded, right? So now, of course, the floor is excluded, so now we're considering these 4 sides. Yeah, well, so you're just gonna say so of course it's gonna be what the answer, let me say total surface area for this thing, it's going to be the area of the roof, right? So surface area of the roof plus surface area of what? Surface area of the roof. I don't know what to say. Let me say the sides. I don't know what to say here, because it will be like for the sides, right? So for the roof we have 10.2, we just calculated it. Here it's going to be 4 multiplied by 3 times what? 2.1. Remember, it's the base times length, right? And to put that in a calculator, let me just do this, right? So I have the answer, which is 10.2 plus we have 4 times 3 times 2.1. Is it 2.1? Yeah, it is 2.1. So then we get what? We get 35.4 meters squared being the final answer for this one. You see, that easy. So let's do this one as last one. You have a metal ball with a radius of 8 millimeters, and then calculate the volume of the metal used, right, to make this ball, right? So number one, what do you need to remember? Their formula, because there's the formula substitution answer. Then the volume we're calculating is the volume of a sphere, because a ball is a sphere, right? So the volume of a sphere, that is 4 over 3 pi radius cubed. I don't know, let me just check whether is it 4 over 3 or 3 over 4, because sometimes that's what I easily confuse. Wait, it's 4, right? 4 over 3. So yeah, substitution. Oh, let me just do it here. 4 over 3 pi. The radius is gonna be what? It's gonna be 4. No. Oh, mola. So it's gonna be 8, because yeah, my mind is like, this is the diameter, but like it's the distance, it's the radius. So yeah, cubed. So I have pi times 4 over 3, 4 over 3 pi 4 over 3, 8 to the power of 3. That is 2144.66. You get me? So number 2, they say if the radius of the ball is doubled, right, write down the ratio of the new volume and the original volume. So this is the original volume, right? So the new volume will be 4 over 3 pi. Then remember, the new volume, we double the radius, so we have 2 times 8 to the power of 3, right? No. Yeah, to the power of 3. And then we're gonna have what? We're gonna have 4 over 3 pi, and then we have 8 to the power of 3, right? Oh no, is to, yeah, because this is the new versus the old, right? The original. So here you already see this is gonna cancel, this is gonna cancel, and then here I can say I have 2 to the power of 3 times 8 to the power of 3 is to 8 to the power of 3. The 8 to the power of 3 the cancels, so you have 2 to the power of 3 is to 1, therefore 8 is to 1. Yeah. And then they say, would you like this ball to be silver? What did I just say? You would like this ball to be silver, right? To be silver plated to a thickness of 1 millimeter. So now what is the volume of the silver required? The volume of the silver required. So now remember, now if you say for example you dip it in a silver painting, whatever, and then when you remove it, you take the ball out, it will be covered with that, it will be covered with that silver paint. That is what, that has like a 1 millimeter thickness. That means your radius, or your radius would have increased by 1 and your diameter by 2, right? So in that case, I can do what? I can say the volume after the what? After volume of this ball, after it has been silver painted, right? It's going to be pi, and then here I'm gonna say 9 cubed instead of what? Instead of 8, because now my radius has increased by 1. So I just go here and say 8 instead. No, 9 instead. So I'm getting 3453.63 meters cubed. No. Millimeters cubed. Did I write the units somewhere? Yeah, I didn't. Please do write the units, man. Please do write the units. So now this is the volume after I have already painted it with the silver. Yeah, this is after I have put it in that silver thing, or I have plated it with silver, giving it the thickness of 1 millimeter. Ne? And then this is the volume before that. So that means if I can subtract these two volumes, let me say view. Okay, if I can subtract these two volumes, I'm gonna get my answer. So I guess I can say V3 for volume at number 3 minus V2, V1. Right. This is the volume of the silver thing, right? It's just going to be the difference between the two, right? Because here we calculate it without that thickness of the thing. Here we calculate the volume with the thickness of the thing. So if you want the volume of the thickness itself, the volume caused by that thickness of that silver plate, it's just gonna be the difference between the two, right? So I can say 3053.63, right, minus 214466. No. Right. So you have 908.97 millimeters cubed. Right. And that closes this video. I hope this was very helpful.